Hello guys, welcome to this video. Welcome to the Hub Beyond Numbers. In this video we are looking at the rules of probability, and specifically we'll be looking at and. Subsequently we'll also look at or, right? So without wasting much time, let's go through what we are coming to do. So we'll look at the concept of and then the rules that regard it, right? And then we'll look at some examples and also solve some practical questions on it. Now, the concept of and in probability. When we say the concept of and in probability, what do we mean? And refers to a simultaneous occurrence of two events, right? And we usually denote it by what you see over here. That is P into bracket A intersection B. The probability of A and B occurring together. That is what we see over here, right? So the probability of two events occurring simultaneously is where we use our and. When we say two events are occurring simultaneously, what does it mean, right? So what does it mean? Let's say you have two dice and you are rolling them all together. You see, so you have two dice, you are rolling them all together. Now, it is likely you will get an outcome in the first one, provided it's still on the board, right? And then you would definitely get an outcome on the second one as well. You see, so with these two occurring together, they are going to have what? Let me see, how would I even put it? The events are going to happen at the same time or simultaneously. This is the first one, which is A, and then the second one, which is B. Right? So A has its own probability and B also has its own probability. You see? And if you are to use set diagram to denote that, this portion here is where they intersect. You see? The portion labeled here is where they do what? They intercept. So with that in mind, there are two instances where we use the and. There are two instances where we use the and. Let's look at them. So the first one is what we call independent events. The first one is what we call the independent event. When you have event A occurring and then B occurring, we say they are independent if the occurrence of one does not affect the other at all. The occurrence of one event doesn't affect the occurrence of the other. For instance, citing the first example I gave, you have two dice. The fact that you are throwing your die and I'm also throwing my die doesn't mean if you get a 6, I cannot get a 6. You see? So, both events are independent of each other, right? Both events are independent of each other. Hence, if you want to find the probability of both events occurring, that is A and B, that is the formula we have over here. That is probability of A times the probability of B. That is both events occurring independent of what? Each other. Okay. Now there is also another instance. So this is what I have done here just to illustrate it. This first one here would be I'm coming. So our first one here will be the probability of A, and this second here becomes the probability of what? B. Right? So we want the probability of both events occurring. All we need to do is to what? To multiply probability of A by the probability of B, and that settles it. Right? Okay. Now there are events that we say they are independent. Let me give a typical example here. You have 10 oranges in a basket. We have 10 oranges in a basket, and in addition to that, we have 5 mangoes as well. Easy. So looking at what we've done so far, the probability of picking, let me write that here so that you would be able to. So we have a basket full of what? 10 oranges and then 5 mangoes. All right, so this gives us a total of 15. You see? Okay, now you are picking a fruit from the basket without returning it back. You see? So if you want the probability of picking an orange, then on our first trial, is going to be a 10 over 15. That is the number of favorable outcomes. In this case, the favorable outcome is what? 10 oranges all over 15. 15 being what? The total number of sample space. This becomes the probability of picking an orange. After picking an orange, now you want to you want to perform another experiment again. Easy. So performing another experiment, this time around the number of orange, you are not replacing it. You see? So the number of oranges reduces from 10 to 9. Same applies to the total. From 15 to what? 14. Exactly. So the probability now of obtaining, if it's an orange you want, or let's say if it's a mango you want, then the probability of you obtaining a mango becomes 5 over what? 5 over 14. You get it? So you realize that the second probability depends on what has already occurred. Right? So you say event A and B are dependent if the occurrence of one affects the other. Hence, if you want the probability of they both occurring together, that is probability of A and B, you are going to use the formula probability of A times probability of B. Then we have this line here, A, that is the probability of B given that A has already occurred. Easy. So these are experiments where the first one has an effect on the second one. Right? So what have we looked at? We've looked at the probability of what? Calculating probability with end. Right? That is when they say two events occurring simultaneously. There is the first one, which is what? The dependent, and the second one, which is what? Independent. Right? And we are saying for the dependent, all we need to do is to multiply both probabilities. Sorry, the independent, all we need to do is to multiply both probabilities together. But for the dependent, where one relies on the other, there to be the probability of the first event multiplied by the probability of the second event, provided the first event has already occurred. Okay, so if that is understood, then let's quickly go to some questions and then see how best we can transfer our knowledge in solving this type of questions. This first question says, what is the probability of rolling a 4 on a die and flipping heads on a coin? Probability of rolling a 4 on a die and flipping heads on a coin. Let's write our parameters down. So let me quickly write that. So we are going to let E of A be rolling a 4 and then E of B be flipping heads. Right? So first of all, before we get the probability of these two events occurring together, we need the probability of rolling a 4. Right? And from our previous video, we said that the probability of an event is equal to the number of the events all over the sample space. You see? So if you want the probability of A, then rolling a 4, we know from coin, the sample space of a coin are 1, 2, 3, 4, 5 and 6. Right? and the event we are considering now, the event of focus is what? The 4. So that is going to be this over here, right? This 4 is going to be the event we are focusing on. Hence, the number of the event we are focusing on is 1. So the probability of rolling a 4 now becomes just a 1 over what? 1, 2, 3, 4, 5, 6 over 6. Then we come to the probability of B. And also in our previous video we said that the sample space of rolling a coin, the sample space of rolling a coin are what? Is that you get a head or a tail, right? In this case here, we're interested in what? A head. So this here becomes our events. And how many do we have in there? Just 1. Okay, so the probability of obtaining a head now becomes what? 1. It becomes a 1 over 2. You see? So now that we have our probabilities, let's quickly now apply our formula. So it says, what is the probability of rolling a 4 on a die and flipping heads? So we know that probability of these two events occurring, A and B, is what? Probability of A times probability of what? B. So substituting, we have probability of A and B occurring to be probability of A, which was what? 1 over 6, times probability of B, which is 1 over 2. Simplifying further, we have a 1 over 12. You see, so we can summarize by saying that therefore the probability of rolling a 4 on a die and flipping heads on a coin is 1 over 6, right? So let's go to our next question. So simplifying, we can have 2 dividing 4 twice and 2 dividing 8 4 times. Multiplying our numerators, we are going to get a 10 over 9 times our 4, which gives us a 36. I think we can still cancel out. So 2 divides 10 to give us what? 5. Then 2 divide our 18 here to give us an 18. Right, so our probability becomes what? 5/18. All right, hence the probability that both balls are red is what? 5/18. All right, 5/18. So basically that is it. We have independent events and then dependent ones as well, and they both have their own formulas. All right, so these are some questions you can try. These are some questions you can try on your own, and then try and see if you understand what has been done. All right, the first one says a coin is flipped and a die is rolled. Find the probability of flipping heads and then rolling a 6. Then the next one says find the probability of flipping a tail and then rolling an even number. The second one also says a jar contains 4 red, 3 green, and then 2 blue balls. 2 balls are drawn without replacement. Find the probability that both balls are red. And then secondly, that both balls are not blue. See you in the next video. Stay safe.